A pointer is a general concept for a variable that contains an address in memory, which that address points to some data. We've already used pointers in Rust, and the most common pointer is a reference. Remember, a reference is with the ampersand sign. These pointers don't have any types of additional capabilities, but a pointer that does give us an additional capability are smart pointers. Smart pointers originated in C++, so it's not unique to Rust. The common smart pointers in Rust are box, which allocates values on the heap, reference counting, RC, which is a reference counting type that allows multiple ownerships, and ref mute, which are accessed through ref cell, which enforces the borrowing rules at runtime instead of compile time. The first one we will cover is using a box smart pointer. A box is the most straightforward smart pointer Rust offers. This allows us to allocate data on the heap rather than the stack. However, the pointer to the heap data is going to remain on the stack. So let's look at a quick example of using a box. We will create a tuple called T, and we'll give it the values 12 and eggs. And then in here we'll create a box, and we'll call it B, and we'll say box new, and then we'll just have it create a reference, aka a pointer, to T. So now we can print out our new box pointer. And I need to use curly brackets. There we go. So now if we run this, we see that our B variable, which is our box, printed out 12 and eggs. And now, so tuples are created on the stack. And then when we created a new box, it was created on the heap, but B was stored on the stack. And then B just pointed to the address in memory on the heap where this was stored. So pointers also come with a dereference operator. So let's first start out with creating a simple reference. We'll go X here. Oh, nope. And X. And X, alright. And now we will make sure that these are equal. And 5 and Y. So if we cargo run this, we actually see that we get an error. And it's saying we cannot compare an integer with a reference to an integer. So what we need to do here is actually deallocate our reference by using the asterisk, and that deallocates it for us. And now when we run it, we see that we don't get that error anymore. So deallocation returns is going to give us the value at that memory address. And then likewise, we can do this with a box. So we will say let x equals 5, let y equals box new of x, and then we'll do the same exact checks again. And if we run this, everything runs successfully. And then just to verify, if we print out our box, we expect 5 to be returned to us. So let's print it out and just verify. And we get 5. And honestly, that is truly all there is to it for boxes. It is a very straightforward concept, and it's just a way for us to allocate data onto the heap.